Hi everyone, welcome back to my channel. In this video I'm going to show you how we can prove 1 plus sine theta over 1 minus sine theta equals brackets sec theta plus tan theta, the whole thing squared. So I give you best strategies in how you can always verify these trigonometric expressions. So if you are new here, please consider subscribing, or leave a comment to appreciate my work. So in this expression, the best strategy I'm going to show you is that first of all, we look at the left hand side, and then we'll look at the right hand side as well, and then we'll realize that what we want to prove is in terms of sec theta, which you can look at in terms of 1 over cos, and then there's tan, which you can look at as sine over cosine. So which gives us an idea that when you are beginning from the left hand side, the best idea is to be creative and then introduce cosine square. So in mathematics, normally we can add, we can subtract, we can divide, as long as we do that operation throughout, the meaning will not be changed. So in this case, I'm going to say that 1 plus sine of theta over 1 minus sine theta is the same as 1 over cos of theta plus sine of theta, everything over cos of theta, then down 1 over cos of theta, then minus sine of theta over cosine of theta. So this is the stage we are up to, and then we can now start interpreting the. So we can see that 1 over cos, that can be interpreted as sec of theta, then plus sine over cos is tan of theta, and then this is over 1 over cos still is sec theta minus tan of theta. So when we get here, we then now think about how do we introduce in now, how do we arrive at this expression on the right hand side. So and down here it's like this is divided by 1, so then the idea is how do we get rid of this denominator, and then we introduce a square. So the idea here that comes to you is the making use of the trigonometric identities of sec. So to do this, I'm just going to continue here and kind of like rationalize. I would say the best way is to find like kind of conjugate of this positive, multiply that up and down. So this means that I'm going to modify this denominator, change its sign to positive, and then multiply that up and down. So that is going to give me sec of theta plus tan of theta. Then again, I do the same thing down because I'm not going to have changed the meaning, then plus tan of theta in brackets, because this at the same time can cancel with that. So all we see is that the upper part, this is the same as that. So this is going to give us excuse, plus tan of theta, everything squared, which you have here. And then over down is like a difference of two squares. So that means we are going to come up with sec squared theta minus tan squared theta. Just recall that if you have a squared minus b squared, this is equal to a minus b, everything into a plus b, which we call the difference of two squares. So this is what we are using to simplify this upper part, bottom part, to come up with this. Also, you can recall that from sine squared of theta, this will become tan squared of theta plus 1 being equal to sec squared of theta. And so in other ones, if I take tan the other side, it will give me that 1 is equal to sec squared of theta minus tan squared of theta, which expression is going to help us to be substituted in the denominator here. And so basically this means that we have sec squared of theta, sorry, uh, which basically means that we have sec theta plus tan of theta everything squared over 1, which is basically what we needed, plus tan of theta squared. And so this is how we can verify this identity. Thank you so much for watching. Please consider subscribing, and also kindly look at other videos where I show you how to prove all other trigonometric identities.